Howdy, welcome back to Advent of Code 2022. This is day 13, so we're over halfway done. Things are starting to get a little harder, and that makes it a little more fun. So let's get started. Distress signal. You climb the hill and again try to contact the elves. However, you instead receive a signal you weren't expecting, a distress signal. Your handheld device must not still be working properly. The packets of the distress signal got decoded out of order. You'll need to reorder the list of received packets or puzzle input to decode the message. Your list consists of pairs of packets. Pairs are separated by blank line. You need to identify how many pairs of packets are in the right order. Okay, let's copy our example. And I'm going to just go ahead and grab the puzzle input. Looks nice and complicated. Let's see. Packet data consists of lists and integers. Each list starts with an open square brace, ends with a closed square brace, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. If both values are integer, then the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are in the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length and no comparison makes a decision about the order, continue checking the next part of the input. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. For example, if comparing 0, 0, 0, and 2, convert 2 to an integer. The result is then found by instead comparing 0, 0, 0 to 2. Okay. All right, so let's look at this first one. 11311 versus 11511. This should be in the right order because, once you get to 3 versus 5, you exit early. So this is very interesting. So you don't compare every single number. You only go until something makes a decision, and then you exit. So I think recursion is in order because that has the ability to exit early. You could also do a for loop, but recursion, given that we have to compare multiple kinds of things, recursion really speaks to me here. Pair 2, we have this complicated thing versus this complicated thing. So without looking below, these two are going to compare equal. And then 2, 3, 4 is going to compare to 4. 4 is going to be converted to a list. And then 2, 3, 4, the first value will compare to the first value. And so 2 versus 4 will compare in the right order. And that is what happens. Okay. All right. I think we got it. Or at least I got it. I don't know if you got it. What are the indices of the pairs that are already in the right order? The first pair has index 1, the second pair has index 2, and so on. In the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of these indices is 13. Determine the pairs of packets that are in the right order. Oh, okay, all right. I don't necessarily. So we have to determine the indice of the pairs that are in the right order. The first pair has index 1. Oh, I see. So we're just doing pair 1 is in the right order, pair 2 is in the right order, but pair 3 is not, therefore you don't add the number 3. Right, so, okay. All right, we get that. Cool. So let's just start with, like always, with reading in the input and setting up our types. So we're going to have, our packet is a union of int and list of packet, right? It's either and this has to be a string here. So it is either a packet. A packet is either a single integer or it's a list of packets, which is either an integer or a list of packets. So you have this recursive list here, and then each pair, right? So we're gonna have pairs is our input, and that is a tuple of 2 packets. Packet, packet. Nice. And then output's gonna be an int. So pairs, and we're gonna do line.raw.split on double new line. And let's see. We're gonna do 2 pairs. Two pair line or lines string. So pair of packets. First, second equal lines dot split lines. So there's only 2 lines in each. And then we have to parse everything as. Well, luckily, this is exactly Python syntax for lists of integers and lists of integers. So we can just use the Python interpreter, right? So Python eval. I like to use the actual Python doc always. So eval. All right, so we can either use eval or exec. I forget which one. Exec, dynamic execution of Python code. Okay, I think we want eval. So we just return a tuple of eval first, eval second. All right, so what does eval do? Eval is going to interpret this as Python code and return whatever it is. And since this is a list of integers or a list of integers or a list of integers, otherwise it should, since we can kind of guarantee our inputs, generally speaking, don't use eval in production code, but this isn't production code. This is a programming problem, so I feel fine using it. Now I'm just going to print the input just to make sure our evals are working. And then I'm gonna day 13, blow this up for you, Python, day 13 example. And we get pairs is, that is not working. We're just getting strings here. Object must either be a string or a code. Maybe exec will work. Not working. Oh, because we're not calling it. Oh, geez, guys. Oh, it's early for me. All right, let's go this. Okay, parse input, 2 pair, line. Oh my gosh. All right. Hey, and that is actually working. So each pair here, I don't know if you can see this. So we're getting a tuple of 11311, 11511, and then 1, 2, 3, 4, 1, 4. Yeah, so this is working. Awesome. So we used eval for great good. Didn't have to parse anything. All right, so now let's make our evaluator something that determines if it's in the right order. In def right order, and we're gonna have P1 packet and P2 packet bool. And this is gonna be a recursive function. So, right, so let's just go, we're just gonna implement these rules, all right? So if type P1 is int and type P2 is int, usually, like if this was like a pure functional language, we would have a big case statement here, but we don't have that. So if the 2 types are integers, we want to return, if P1 is less than P2, return True, we are in the correct order. L if P1 is greater than P2. We're assuming P1 being the left, right? Actually, yeah, we should call this left and right just to be consistent with the explanation of the problem. I know it's a little pedantic, but when we're debugging this, it will help us. I mean, if we do it right the first time, then we don't need to debug it. P1, P2 would have been fine, but I've been tending to have bugs the last few days. So if left is greater than right, then we have to return false, and else otherwise we have to return some other value. So we can't actually, we need a third return value. Correct? Yeah. So we're gonna have a, we're gonna return optional bool. We're gonna return none. And we'll have to be careful because we had a truthiness bug a couple days ago. So this, we're gonna have to make sure we test correctly, but it should be good. All right, else, elif, so type left is list and type right is int. Then we wanna return right order of left and right. Right, so if the right is an integer and the left is a list, we wanna convert the right to a list. And then we do the same thing for the other side. So elif type left is int and type right is list, return right order left right. Okay, else, so otherwise both are lists. So we do for left value, right value in zip left, right. Now we have to look at the Python doc zip. We have to look at the documentation for zip real quick because we need to make sure that it is like what happens when the two lists are not the same size. So it ends here if zip, by default, zip stops when the shortest iterable is exhausted. But there should be a way to, you can use itertools.zip longest with a fill value. Okay. So we're gonna do that. Import from itertools, import zip longest. We're gonna do zip longest. So zip will zip up our two lists, so we'll return tuples of the left and the right, and then we'll have fill value equals none. And so what this will, let's make sure I did that right. Ooh. Fill value does not have an underscore. All right. So, all right, compare the first value. So if right, all right, so compare equals right order, left value, right value. If compare is not none, return compare. So if it's a Boolean, then we just return right. If it's in the right order or not in the right order, then we just return it. If the right list runs out of items first, and then we have to do, so if it is none, then we just keep going, right? But the first thing we got to check is if one of these values, if left value is none, meaning the fill value is none, meaning that it is, we are empty, we have exhausted the list, then we return true, right? Because if the left list runs out of items first, the inputs are in the right order. Else, if right value is none, return false, else run the comparison, right? And if the comparison is none, then we keep going. We go to the next value, so then we won't have any return. And then if the lists run out and we never return, then we continue checking, so we return none here. Okay, I think that is all of these three rules done. So I'm going to go ahead and do it. For I in range, for I enumerate input dot pairs, index equals I plus 1, sum equals 0. If right order pair, oh, I forgot to take the pair. Sum plus equals, well, I plus 1, right? So, and when that's it, return sum. Okay, let's test it. Right order, missing one, required argument, right. Okay, pair. Stare. 13. 13, correct. Okay, let's try it on the input. 5366. Correct. Okay. I mean, we just implemented the rules as they said in a recursive way. So, and we didn't write any bugs. So we got it right. That was good. Part 2. Now you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal also requires you to include 2 additional divider packets. Okay. Using the same rules as before, organize all packets, the ones in your list of received packets as well as the 2 divider packets, into the correct order. For example, the result of putting all the packets in the correct order is this. Okay, so we have to sort them. Oh, this is cool. Okay, cool. So we have to implement a sort function. But luckily, with our own comparison. Does Python sort with comparison? Comparator. Comparator. Because the way Python sort works, it uses a key. FuncTools has a comparison function. FuncTools, Python. So most languages have a comparison function or a comparator to do their sorting, their custom sorting. But Python has a key function, which is not the same thing. So since we can't really map this comparison to a value, we can only do this. So this FuncTools CMP to key, used with tools that accept key functions. Okay, a comparison function is any callable that accepts 2 arguments, compares them, returns a negative number for less than, 0 for equality, positive number for greater than. All right, so what I'm going to do is say, all right, key equal, we're going to, from FuncTools, import CMP to key. Key equals CMP to key, lambda left, right, 1 if right, we have to, all right, so we got to do right order compare left, right, compare equals right order left, right. And then we do if compare equals true, return 1, elif compare equals false, return -1, else return 0. So this will map our right order function to a comparator style return value. Okay, and then we do key equals CMP to key right order compare. So we map this compare function to a key function. Then we do, then we got to get all packets. So packets equals, we got to do our two divider packets and plus input packet for pair in input.pairs for packet in pair. So this will give us every packet in the input and plus our two divider packets. Then we do packets.sort key equals key. So we mapped a comparison function to a key function. Okay, afterward, locate the divider packets. To find the decoder key for this distress signal, you need to determine the indices of the two divider packets and multiply them together. Okay, so then we do div2 and div6. We're gonna set these to be ints. For packet in packets, for I comma packets, enumerate packets, if packet equals 2, div2 equals I. The first packet is index 1, so I plus 1. elif packet equals 6, div6 equals I plus 1, and return div2 times div6. Let's see if this works. 45. Ah, we got 140. That's wrong. So we get 10 and 14. So what we want to do is we're going to print our sorted packets, right? Did we do it right? Print packets. We're going to do for packet in packets, print packet. All right, so this did it in the wrong order. It actually did it exactly inverted. Okay, so that's pretty easy to flip. We just do -1 to 1 here. Rerun the example, we get 140, which is the correct answer. I'm going to remove the debug statements and run on the input, and 23391, submit, correct. Awesome. I really enjoyed this problem. I like recursive functions. I like leveraging the built-in sorting algorithm with this custom kind of sort comparison function. You know, I suppose you could write your own sort if you wanted to do that, but we don't live in 1980 anymore, so you can leverage the standard library for that. Yeah, I hope you guys enjoyed this one. I really appreciate all you guys watching. I noticed there's some people I don't know watching and commenting, and I really appreciate you guys and gals and non-binary pals, all those people. So I'll see you guys tomorrow. Peace.